Hello friends, in this video we will explore about exception bubbling. In Java, a method can call other method, and the called method can call some other method, and it can continue till the called method returns. So we know that these methods are stays in a call stack. Alright, so now we will explore the role of exception and how it will get handled when there are multiple methods in the call stack. When an exception is thrown in one method, the exception will search for a matching catch block in the current method. So in the current method, if there is a handler, then the exception will get handled there in that current method itself. But when there is no handler on the current method where the exception is raised, then it will walk down in the call stack to search a matching catch block. So this travel continues till the very first function in the call stack. So that's how the exception flows down in the call stack when it is not handled. Alright, this travel continues till the exception finds a suitable handler. So we know that static void main is the entry point in Java. So we can say that the travel continues till that last point. So if it is not handled even in the function entry static void main, then Java will treat that as an unhandled exception. So when JVM sees this unhandled exception, it terminates the program execution any further. So that's why you will see in your console window that the exception is not handled. After that, the application quits. Alright, so when we talked about the exception occurring in one function, then it is traveling down in the call stack tree, searching for a suitable handler, is called the exception bubbling. So usually the bubbling happens from bottom of the water service and it reaches the top. Here in the call stack analogy, if an exception occurs in the topmost function in the call stack, then we will do a stack walk from top to bottom approach, searching for the handler for that thrown exception. Let us see this picture really so that we will get more picture. Let us say there are two functions, fx and fy. Let's also assume the function fx calls the function fy. So here is the function fx that is calling fy. Let us also consider that there is one more function called fz, and fy is calling that function fz. Now let us say an exception of type t is raised in some of the statement in the function body of fz. So when the exception is raised in fz, the immediate stuff what Java do is it will look for a catch block. First it will make sure whether it is in a try block, then it will look for a catch block. So the exception tries to find a catch block handler in fz. So if it fails the exception, if it fails to find the handler, the exception is handed over to the calling function. Here, if you look at the picture, the exception is raised in function fz. Either fz may have try catch block or it may not have try catch block. So if the statement that is raising the exception is not inside the try block, then exception T travels back in the call stack. That means the exception T is handed over to the function which is calling the FZ. That's one case. The secondary case is, even though if we find a try catch block in FZ and exception T is not matching with any of the catch block, then also we will travel down to the call stack. That means the exception T is handed over to Fy, because Fy is calling FZ and FZ is not handling the exception T, or exception T doesn't find any matching handler in the catch block. So in that case, the exception travels back in the call stack and it is handed over to Fy. So the same rule is applied. So if Fy is having a matching catch block, then exception T will get handled there. And if it doesn't have any handler in Fy, then it is handed over to Fx. So that's how the exception travels down in the call stack till it finds a catch block. So the travel ends at static void main. If we have a handler there, then it will get handled there. Otherwise, the exception goes unhandled and JVM halts the program execution. So the traveling of this exception from FZ to Fy and Fy to Fx is called the exception bubbling. Alright, let us see this in Eclipse with an example. So here is the exception bubbling demo. We have only one Java file, main entry. Here we have 3 static functions, because we are going to call this function in void main, which is static. Alright. So see, function X here is calling function Y and function Y is calling function Z. Right, so this function X is called by the void main here. So in the main, if you see, we have a output statements before and after calling the function X. So we are saying main entry, main exit. Then in function X, what we are saying before calling function Y, then we are saying after calling function Y. So function Y we kept inside the try block. Notice that the try block is not in all 3 statements. So only function Y is enclosed between try and catch. So we are placing like this because the statement is not related to function Y, or function Y is not going to provide any information to system.outline. That means even without calling the function Y, we can still print this statement. So we can say that this statement is not dependent on function Y. Similarly, function Y is not dependent on this particular statement. Alright, so that's why we enclosed this within a try catch block. Let us say we form some argument here in this statement, then we are passing that to this function. Then function Y depends on the previous statement. Also, let us consider function Y returns something, and based on that return value we make some calculation. Then we pass that return value to some other function to do additional task. Then in that case, these statements depends on function Y. So that's how you will end up with expanding this try block to all these 3 statements. Why? Because each one depends on each other. So when something fails, we don't want to execute the remaining statement. Alright. So here in this example, we enclosed the try block within the particular function call. In function y, we are placing some output statement before and after calling the function z. In function z also we have similar statement before and after executing some set of statement. Here we intentionally kept x divided by 0. So we know that this will raise arithmetic exception. But if you look at the function here, we don't have any try catch block. That means there is no handler for the exception that is raised here. Let us say we enclose this with a try catch block, and the catch block is handling only one exception, which is called array index out of bound or file not found exception. So even though we have try catch block, this particular exception, arithmetic exception, doesn't find a matching handler here. So in both cases, the exception is not handled inside the function z. So what happens? The called function, the caller is function y, and it called this function here. So what happens? The exception is bubbling back to function y at this particular statement. Then it will search for is there any handler on this fy. So we doesn't find any handler. So what happens? The exception once again bubbles back. So here luckily we have a handler for this function y, and the exception raised here at this statement is arithmetic exception, and a handler for that arithmetic exception is found here. Even if there is a exception ex, because arithmetic exception is derived from exception ex, so it will still find a match here. So in this example we have the exact arithmetic exception, so it finds a match, so it will execute, the exception is handed over to this catch block. So that means here the exception is handled. Since the exception is handled, after this call the execution resumes. That means it will print this statement. So that's why I'm saying if these statements are independent to function y, we can continue our execution. But if the statements are dependent on function y, then this should move inside the try block so that this statement will not get executed. Why? Because the flow is like this. From here we came to this particular line, then we traveled deep inside the tree, then exception is thrown, we bubbled back here, no handler, we bubbled back here, and we are ending up here and we are finding a handler. So if you place some statement after this inside the try block, that will not get executed. So here the arithmetic exception is handled. So since the exception is handled, when we come out of catch block, the remaining statement will get executed. That means after calling function y will get executed, and then call returns back to the main, and main even doesn't know that there is some exception it got handled. Why? Because the handling stuff will ended at function x itself, so it doesn't know about arithmetic exception at all. So what it thinks, function x returned normally, so it prints main exit. Now let us say the exception is not handled here, or there is no matching handler here. What happens? The exception bubbles back to the program main entry. So if we don't have any handler here, then Java will throws unhandled exception, then it will exit the application. That means you will never see this statement. The application is crashed here itself. Alright, now we will execute. So we already have a breakpoint at function x. So here this is thread main, this one, and you can see how our call stack is growing here. So at present we are at function X and we already saw the main entry. So this one get printed in the console window. Let us jump inside function X. Before calling function Y is printed, then we are stepping inside function Y. Before calling function Z is printed, we are calling function Z. So it states before division and it assigns value 4 to X. And if you look at the call stack, program main entry, then function X calling function Y is calling function Z. So now, since the statement raises an arithmetic exception and there is no handler here, the exception will get bubbled to next statement. So the bubbling goes like this: function Z to Y and then Y to X. Let us see that. So I'm trying to execute this statement, and if you see, it bubbled back to function X. So from here, the call stack for function Y, from function Z, we jumped back to function Y. That is not shown here. Then from function Y, we jumped back to function X. So if you place a try catch handler in function Y, then you will be seeing that it reaches the catch handler in function Y itself. I'm leaving it for you to experiment. So now if you look at here, since we saw an exception is thrown here, we doesn't see these two statement. That means the value Y is not printed here in the console window, and this should be after division. So we are not seeing after division. So after calling function Z, that statement also we are not seeing. We are seeing only before calling function Z. That means it returned from here to function X. And in function X, we will see that the exception message get handled. It says division by 0. After that, the execution resumes to the statement which is after the catch block. So it will print after calling function Y. Then the execution resumes to main, and you will see main exit. And this main function doesn't even know that there is some exception that occurred down in the call stack, and it get handled before the function returns to main. So it just prints main exit. Thank you. If you like the channel, subscribe. Bye.